We are now going to briefly look at determinants and matrices. Determinants is a very powerful tool. There can be an entire class in college you can take on this if this interests you. We're just going to kind of look at the calculations and see what they are about just a little bit, and then that'll be about all we do in this class with them. So first of all, a determinant is a numerical value that kind of represents the matrix. If you see these brackets like that, that means you're dealing with a matrix. Okay. The determinant right here, D stands for determinant. These bars right here, that means they want you to find the determinant. So if it says find the determinant for this matrix, or it says these bars, that means they want you to find the determinant value of that matrix. So this is how it works. If you go down, down, down to the right, that is going to be positive. So that gives us A times D. But anytime you go down, down, down to the left, okay, that's going to be negative, or you have to subtract. We're going to subtract the value of B times C. All right, let's try one. It says evaluate, and I noticed that there are bars on this, so that means they want us to do a determinant. So let's go down, down, down to the right. 3 times 1 is 3. And anytime we go down, down, down to the left, we're going to have to subtract. So let's subtract this value right here, which is negative 12. So we have 3 minus negative 12, which gives us 15. 15 is the value that represents the determinant of that 2 by 2 matrix. Now, if the matrix is a 3 by 3, it's going to get a little fancier. So the first thing we have to do is take these first 2 columns like this, and we have to copy them outside. So there's the first column, and then let's take the second column and copy it. Okay, you're going to see why in just a second. We're going to need those values. The same values that are in the matrix, we're going to need them out there. So the first diagonal going down, down to the right, 2 times 5 times negative 9 is negative 90. Okay, and then plus. Now we're going to go down, down, down to the right with another diagonal. Oh, I'm so glad I wrote that 0 over there, so my diagonal can capture it. Anything times 0 is 0. Okay, plus there's going to be one more diagonal. 3 times negative 2 times 6 is negative 36. All right, now it's time to do our 3 diagonals down, down, down to the left, and these are going to be negatives or subtractions. So I'm going to minus the first value. Oh, thank goodness. I love it when there's at least just 1 0 in there. It makes it a little easier. Then we'll subtract 2 times 1 times 6, which is 12. And then we subtract our last diagonal. Negative times negative times negative makes negative 18. Negative 18. A negative minus a negative here is going to cancel, and try to do as much of this as you can without a calculator. It's good practice. Add up all the negatives, and then subtract off those positives, and the determinant is negative 120. Okay, that's how you do the determinant of a 3 by 3. This one's kind of fun. It says solve for x if, okay, and it says right here, it says determinant equals to 7. So that's telling us that determinant is 7. So what I'm going to do down here is write out our 3 by 3 matrix, copying all these values here. And then outside of that matrix, I'm even going to copy the first 2 columns there like that. Okay, and now it's time for us to calculate the determinant. So let's go down, down, down to the right. Oh, this is getting interesting. X times negative 2 is negative 2x squared. All right, let's do it again. Plus the next diagonal is 0. Plus the third diagonal, 3 times 1 times 1 is 3. Now it's time to do the diagonals to the left, so I'm going to switch to my red pen for the negatives. Let's subtract the first value, 3 times 6 times x. That's 18x. And then let's subtract 0. And then we will subtract 2 times 1 times negative 2, which is -4. So what we've just done here is we've done a little calculation, and all of this stuff right here, all of these values, are the determinant. It told us the determinant of this matrix was a 7. So this calculation, this determinant, must equal 7. So it seems like we have a quadratic equation to solve. Let's move everybody to the right since that's a negative. So we've got 2x squared, and we've got plus 18x, and then 3 plus 4 is 7. Okay. So it's a binomial with just two terms. I'm going to solve this by factoring. I'll factor out 2x. That leaves us with x plus 9. So there are two values here. X could either equal a 0 or x can equal a -9. If you replaced these values here in this matrix with zeros and did the determinant calculation, you'd get a 7. Or if you replace those values with -9, the determinant calculation would also equal a 7. Okay, that's as far as we're going to go with determinants being either 2 by 2 or 3 by 3. The next thing we're going to look at here is matrices. And the hardest part about this is going to be all the words. Okay, so first of all, systems of equations can be written in matrix notation. And the matrix that you use to represent a system of equations is called the augmented matrix. So again, the hardest part is probably going to be learning what these things are called. Okay, very easy to do. Write the system of equations as an augmented matrix. So what we're going to do here is write a matrix, and this is how you set it up. We have x, here's our column for the x's. Then we're going to have y, a column for the y values. Then you're going to put a bar, and the bar represents the equal sign, and then this over here, this is where you put the constants or the numbers. Then you simply take your system of equations, you take the coefficients, it's 1x, I'll put a 1 there, y gets -2, and the value there is 2. In the second equation, there are no x values, so that's going to get a 0, that's going to get a 1y, and that'll get a 3. And that is the augmented matrix. Very easy to do. You just take the numbers and you put them in a box form. Okay? And the vertical line serves as a reminder of the equal signs. Okay, that's called the augmented matrix. Another type of matrix that we're going to use a lot is the reduced row echelon form. Reduced row echelon form, and that's called RREF. The reduced row echelon form is a matrix, and all entries on the left-hand side, on the left of the vertical line, are either zeros or ones. Ones are found along the diagonal, representing the variable. Okay, for example, take a look at this. This one right here is a reduced row echelon form. Okay, everything on the left is 0 and 1s. See how there's 1s going along the diagonal, and everything else is 0. So let me show you what this means. If this is the x column, and this is the y column, and here's the number column, this first line right here says 1x, no y's, equals 8. And then the next one, there's no x's, 1y equals to 3. So if you have it in this form, you essentially have the answers for x and y. Each column or each row there only has one variable. Okay, let's practice this a little bit. It says write the augmented matrix. Okay, that's the easy step. Okay, here's the augmented. Augmented. So we're going to have a 3, and it's always one long. It's always 1, 2, 3, 4. It's never a square because you always have that number column. So I'm going to put the vertical line right there, put that bar. And our first equation says 2x, 2y. Our first equation doesn't have any z's. So let's put 2, 2, 0. And the constant is 6. The next equation has 1, 1, 1, and a 1. And then the third equation has a 3, a 4, a -1, and a 13. That's the augmented matrix. Not a whole lot of work. You just take the equation and you write it in a matrix form. Now, for step 2, It says, write the reduced row echelon form. And we just call that RREF. Okay. Now, I know what it's going to look like. This is kind of what we're hoping for here. And you don't usually know this till you find it. But if it's working out correctly, what you're going to get is ones down the diagonal. And then what you'll get is zeros everywhere else. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now where is she getting that from? Well, I'm not getting it. I'm just telling you that that's what we're hoping for. We are going to do all this work with our calculator. So the first thing I want you to do is find your calculator, clear it out, turn it on, and we're going to find our matrix command, which is above the inverse button. So we're going to hit second matrix. Okay, and the first thing we're going to do is we're going to go edit matrix A. We're going to edit matrix A, so go over there and hit enter. And matrix A needs to be 3 by 4. Mine already was 3 by 4. If this is the first time you're doing matrices, you might have to change those numbers, and it's going to make a matrix the right size for you. And we're going to type a 2, enter, a 2, enter, a 0, enter, and a 6, enter. Then you go across the second one. 1, 1, 1, and 1. Keep going. 3, 4, negative 1, 13. And I've just typed in all the values for my matrix, which I called A. I want to make sure I don't make a mistake. If you make one typo, everything's wrong. So everything's saved. You're just going to hit second quit. And now what we're going to do is we're going to go back into the matrix command, and we're going to grab matrix A. Okay, I called that one A. There's the name. If you hit enter, is this the matrix you intended to type? Let's just double check for any typos. If your matrix A looks good, then we're ready to start. Okay, I always double check to make sure I typed in what I thought I wanted. So we're going to go back into matrix, but this time we're going to go into math. Oops, what happened? Go into math. Go into matrix, go into math, and we're going to go down, down, down until you find reduced row echelon form. My command is a B command. It might be the same for you. So we're going to grab reduced row echelon form, but we have to do that of what? We have to do that on your augmented matrix, which you called A. So you go back into the matrix, and you grab the name A. So we're going to reduce row echelon form matrix A, and then you hit enter. Perfect. Exactly what I was hoping for. 1, 0, 0, 1. The second one has 0, 1, 0, 2. 0, 0, 1, and a negative 2. Okay, this matrix right here is in reduced row echelon form. And what that means is we have the values of the variables. See this first equation here? It says 1x, no y's, no z's is equal to 1. This number right here is in the y column, so that's y equals 2. And the last equation says z equals negative 2. So if you have a reduced row echelon form matrix, you essentially have the solution. Now this is how you state a solution. You always put it in parentheses and you list the variables in alphabetical order. So I need to say the answer is 1, comma 2, comma negative 2. This is how you state the solution. This is the matrix. Okay, this is reduced row echelon form, but that is how you state the solution. So we're essentially solving systems with our calculator. Okay, let's do it again. What size matrix are we going to need for this system here? It's got 3 equations, so we're going to need 3 by 4. So let's write out the augmented matrix. So the first equation gets 1, negative 1, 1. Let's put the bar, and we're going to get an 8. The second equation needs 2, 3, negative 1, negative 2. And the final one gets 3, negative 2, negative 9, 9. Now that's the augmented matrix. Okay, and what we need to do is get the reduced row echelon form matrix. So let's go ahead and pick up those calculators again. Go back into your matrix command. And I'm going to edit matrix A again. A is the perfect size, 3 by 4. I'm just going to type in that one. Okay, so we've got 1, negative 1, 1, and 8. 2, and a 3, negative 1, and a negative 2. 3, -2, -9, and 9. Now what I am going to do here to make sure to make any typos is quit. And I'm going to ask my calculator to please display matrix A. If I made any typos, that's going to mess everything up. Does your matrix look like mine? Okay, now what do? We want to solve this system. So we need to go back into matrix. We're going to go to math. And since that command, RREF, was so low, I think I'm going to arrow up. Because there it is. So close to the bottom, I like to go up. You're going to reduce row echelon form, matrix A. Please take that matrix and reduce it for me. Perfect. Ones down the diagonal. Okay, so people are usually really good at this point of just looking in their calculator, and we can state the solution. Okay, remember, the solution is a point with 3 variables. The first equation says x equals 4. The second value is -3 for the y, and 1z equals 1. There's the solution. You can totally do all the calculations here with your calculator. Number 7, solve this dependent system of equations. Are you guys getting pretty good with the augmented matrix? Maybe we can just go straight into the calculator just by looking at this. That would save some time. So let's try that. We'll go into matrix, and I believe we need another 3 by 4. So matrix A, you're up again. And make sure the letters are in order. 6, -1, -1 and 4. Next equation, -12, 2, 2, and -8. The third equation is 5, 1, -1, and 3. Let's just make sure I like the way it looks. Did I make any mistakes? Does yours look like mine? If it does, then I believe we are ready to start. So we're going to go to reduced row echelon form. Let's go back into matrix. I'm going to arrow up to the B command. Let's reduce row echelon form matrix A. Oh, yuck. This is all over the place. What I would like you to do right now, while you see this matrix, is go to math, and let's get the number 1. Turn that matrix into fraction form. Oh, that is so much easier to write down. Okay, so the reduced row echelon form for this one has a 1, a 0, -2/11, and after the bar is 7/11. Something weird is happening here. -2/11. The last equation has nothing but zeros. So I don't see ones down the diagonal. I was having a hard time solving things here. So let's give this some meaning. This first equation says x minus 2/11 z equals 7/11. So it wasn't able to solve for the variable. This next one's also an equation. Y minus 1/11 z equals 2/11. So those are in terms of each other. This last one right here, this is the one that's going to give it away. This tells us what's going on. 0 plus 0. So this says 0 equals 0. When you get something weird like that, 0 equals 0, that is true. When you get something true, you know what the answer is for this equation here? Infinitely many. Same as if you were to solve it by hand. Okay, so we're going to go through these examples here. If you get something weird, you're going to have to make sense of it. You have to try to figure out what your calculator is telling you so you get the right answer. Okay, don't just say you can't do it. All right, let's do this next one. Something weird's going to happen, and I want to make sure that you know what's going on. So if you see something weird, you don't freak out on a test. Let's go back into matrix, and we're going to edit A. 1, 1, 1, and 6. 2, -1, -1, and 3. 1, 2, 2, and 0. Okay, I'm just going to make sure that my matrix is right. Does yours look like mine? Or take a second to catch up. And now it's time to reduce row echelon form your matrix A. And the reduced row echelon form of matrix A is, Oh, that doesn't look so bad. 1, 0, 0, 0. 0, 1, 1, 0. 0, 0, 0, 1. Okay, let's see here. This first one says x equals 0. There's nothing wrong with that. That is a good answer. 0 is a value. This next equation, though, says y plus z equals 0. So that one's in terms of each other. But this is where it gets weird. What does this equation say? It says 0 equals 1. And 0 does not equal 1. Okay, that is not true. When you get something that is false, remember what you're supposed to say? No solution. Okay, in fact, if we look at the directions here, it says solve this inconsistent system. So I knew that we were going to get no solution. And this one says solve a dependent system. Now this is just for practice. I'm certainly not going to, on a test, say solve this dependent system. I'm just going to say solve the system, and if you get something weird, you're going to have to make sense of it and make sure you say the right answer. Okay, have fun with those calculators.